started with the evolution of flexography. So the early days of flexography, we're talking of end of 18th, 19th century, the early days of the 20th century, and we're talking of one industrial age where the industry was still trying to find a kind of a settlement, a kind of a method of working. And the first applications of flexographic printing plates were really made by handcraft engraving, right? Then we moved to vulcanized rubber. Then there was the age of photopolymers that came into action, but we are talking already of a jump of several years. And finally, we have elastomers. When thinking about hand cutting, well, we can consider it today rather a form of art. Okay, so when you see there are some block printers around the world, but they use this method of hand cutting or hand engraving just for artistical purposes. But you think that in the past we used to have this activity related to actual industrial production. Of course, we are talking of the production of some graphic objects, very simple graphics like, fragile or the sign of the umbrella, just to identify that the package was containing something that needed to be protected. And the message that was given by the flexographic printing was really an informative message about the contents of the package. For a very long period, we used to have vulcanized rubbers. It's funny because, even today, if you go to Germany, flexography is still called Gummitruck. So gummi is for rubber, right? So the name of, and in Italy, when you mean the plates, in Italian they say le gomme, the rubbers, because it used to be the major component that was used to make these printing plates with the vulcanized rubbers. And still today we have a restricted number of users doing some very simple printing onto very rough material that need to be either decorated or marked with certain symbols. We have vulcanized rubber thanks to Mr. Charles Goodyear, that we know for tires, probably the name, and in the some years ago he discovered that adding a certain sulfur to the latex of the rubber, coming from the latex of the rubber tree, combined with heating and time, resulted in a certain resistant and elastic compound, very nice to make printing plates. So after more than 100 years, this process was used to make rubber printing plates for aniline printing. And how does it work? It worked with a plate that was made with a typical letterpress printing plate, with the lead, tin and antimony leagues of metals, and they were actually pressed against a sort of a carton, okay, a carton that molding carton that with pressure, temperature, time, and certain humidity, it could get an imprint of our relief printing plate. So we had this hard metal printing plate that received this imprint. Now, after we take this carton, we can get a piece of rubber, okay, natural rubber or other compounds made of rubbers. In the years we could see many different rubbers that were developed, like nitrile butadiene rubbers or EPDM, for different resistances, chemical resistances against certain inks. And with the same system, pressing the rubber with temperature, time, and heat, like Mr. Goodyear invented, we could finally get our printing plate. And the printing plate could then be used to be mounted on a cylinder on a printing press. So this method of matrix molding was actually derived from a similar method used in letterpress, where they used to do this molding and to obtain by fusion of these metallic leagues of lead, tin, and antimony to print in rotary letterpress. For the same, with the same or similar system, we could have our vulcanized rubbers. So here actually we are talking of vintage or ancient methods for the preparation of a flexographic printing plate. A more modern way of making this printing structure was given by the use of photopolymer resins. The first resin that was used was this liquid photopolymer. When we say liquid photopolymer, photo is the prefix photo means that there is something that reacts with the light. Okay, so it's a liquid polymer that could be hardened by the action of an exposure to radiation, and that was UV radiation. So liquid polymer is still used today for the preparation of thick and soft printing plate, especially with for the production of corrugated printing, where we need to have a thick plate for our needs. So normally, working with a crystal plate, we had a negative film carrying in negative, of course, the printing images. So I mean, the printing image is transparent and the non-printing is black, covering the emission of the radiation. With the help of a protection layer and with the definition of the certain thickness of the layer that we need to obtain, this liquid resin was poured, or is poured, into this kind of a sink, okay, provided by these thicknesses on the sides, and a protection layer is added, or a base layer is added to the bottom. Well, I say the bottom. You can see it like at the top, but this we are looking at the bottom of the plate. So the plate here is facing upside down, facing down, masking the non-necessary areas in order to avoid the complete polymerization of this resin. We could then start the process of polymerization. Polymerization means that by the means of this ultraviolet radiation, the polymer hardens. Okay, it hardens and it becomes it looks like a vulcanized rubber. Not exactly, but very similar. And after this, we can remove this plate from the exposure unit, and what you see here, like a still darker polymer, is one area that can be recovered. So this polymer that was not polymerized can be reutilized for future use. Okay, so one good interesting thing of these polymer plate, liquid polymer plates, is that we actually polymerize only where necessary, because all the other polymer is then taken back to the container and reutilized for future use in our process. Okay, so here we have some examples of a flexo plate still mounted on a washer, where we are rinsing away the polymer and cleaning better or the printing and non-printing areas. So this making of the flexo plate is helpful to explain one aspect of the flexographic printing plate. As you see here on the screen, you can see some printing plates where we have actual printing elements like the characters here, or the step wedge with a solid with a negative print. And then we have another part that is not supposed to print, but it actually helps the printing areas to reach the printing level. Now, so why do we need that base? We need that base because when we build a plate, if we needed to do, let's say, a solid surface, okay, we just needed to polymerize the area, the necessary area. That's it, right? But in case we needed to do any tiny object, any tiny a rule or a line or a dot or a character or whatever of little dimensions, you can think how easy and how critical the size of this printing element could be in terms of being resistant to the movement, okay, and possible errors and possible problems that could create in printing. For this reason, what we do is to build a base to reinforce the printing element, okay? So we let only the necessary relief part to be compressed or to be used for printing. So in this way, we avoid these vibrations, this movement that could potentially create some problems. Working with liquid photopolymers, then we can say, okay, but why do I have to polymerize the full base of my plate? I don't need that. And if I don't polymerize the complete base, then the non-polymerized polymer can be reused, and I can save money, or I can avoid to waste this material. For this reason, liquid photopolymers are normally produced by restricting the area just around the necessary part. So if you have a look, this is a very small sample I have here. I use with my students just to show them as a handout. And you can actually see how a base is built, and over the base we actually have the printing relief that we need for printing, right? So if you have any questions, don't hesitate, just interrupt me whenever you want, okay? So if there is any request of information or any doubt, whatever, okay? So don't.
Or you can click reaction and like hand up your hand and smile.
Well, this is something I wanted to do after this, but I can yes, okay. One question I wanted to ask, if there is any of you working with liquid photopolymers, and meanwhile we can listen to. I do not know the Moazzam, the username.
Yes, Moazzam here. I have a question on the plates actually. No, we are not in Tetra Pak. We are not working with liquid. Answering to your question. For the plates, I just have a question. We get there are of course less, but some few suppliers available for plates, and we tend to distinguish them based on their quality, their softness, and some other attributes. Mm-hmm. Are you going to go in detail on
absolutely. Absolutely.
Yeah. Okay. Fine. So
every attribute, every feature, everything. Absolutely.
Yeah. Then it's fine. My question was actually related to more how the plates quality are affected from which parameters, and how we can know as a process guy to while feeling the plate, that how it will impact our printing. So
yes,
that was my question. Yeah.
Absolutely. You're gonna get your answers in within the next slides. But when talking about the features of something, for me it is very important to explain why we need that particular feature. Where does it come from? Okay, so in this way it is more understandable for everybody. So let's speak now about the majority of flexographic printing plates that we have in the market that are made from solid photopolymer plates, right? So here we have so many different types with different hardness, with different colors, with different thickness, with different flexibility. So the will affect and will contribute to printing quality. First of all, we have seen the liquid polymer, and now we have a solid polymer. Why do we have a solid polymer? Well, the primary reason that a solid polymer was created was to ensure to the user to receive a plate with a perfectly calibrated caliper thickness, the gauge, okay? So to avoid to have inconsistency. So the work of the first producers of solid photopolymer plates, DuPont, BASF, then became Flinter and Axis now, their first, the primary objective was to provide a consistent thickness of the plate. So this way, this allowed the industry to set onto certain standards of production. Okay, I have one. Okay, here. There was a participant in the waiting room. Not sure. Okay, Tatiana. So I think, Tatiana, I think I can make you co-host. Okay, so you can. Okay, so we can share the host functions,
Okay,
and
thank
you can activate whenever the. I haven't understood if the person was out because of loss of connection, or
I'll check.
just arrived late. But okay, so now you are co-host, so you can handle these things. Now, okay, so the purpose was to provide a consistent thickness of the plate. Now, on the plate. Then we will see how we will make it, this. We create one negative image. It is either with a separate film or imaged on the surface of the plate. And then we make the polymerization. Making the polymerization means to build the base of the plate first, and then to create the relief image. Okay, so this is the principle is exactly the same as the liquid photopolymer, but here we're working on a structure that was pre-made by our plate suppliers. And with a method of removal, developing or processing, we can take away the non-printing areas that were not exposed to the radiation of to the polymerization radiation, and we get our final plate. We will see that there are some other little things to be added onto this process, but we will see later. Okay, so this is just the principle of making the plate.